Hello everyone, welcome to Vishesh Educational Videos. In this video, I am explaining about the informal design guidelines for design of a relational schemas. That means it is going to tell about what are the steps you need to follow while designing the database. That means you need to design a database in such a way that there is no redundancy, and also you should organize your data in the database in a efficient manner. So while designing a database, there are some guidelines you need to follow to avoid the redundancy and to efficiently organize your information. So in this video, I am explaining about that guidelines that are needed while designing the relational schemas. So why we need guidelines? So while designing a database, we need to design a database in such a way that it should not contain any redundancy. What is redundancy then? Redundancy means, right, storing the same information in different places. You can't store the same information in different places, right? So if you are storing the same information in different places, that can be called as redundancy. So while designing a database, you need to make sure that redundancy should not be there, and also along with that, data should be in a proper format, right? You have to store the data in such a way that it should be in a proper format, and also it can be easily accessible. Getting, guys? So why we need guidelines? So we need guidelines to design a database in such a way that it should not contain any redundancy. That means the same information can't be stored in different places, and also we need guidelines to store the data in a proper format, and also we can efficiently access that data. So for this purpose we need guidelines. So total there are 4 guidelines are there. These guidelines we need to follow while designing the database. Now I will discuss each guidelines in detail. So what are those guidelines? The 4 informal guidelines are: first one is semantics of the attributes. I will explain each guidelines in detail. Next is reducing the redundant values in tuples, and third is reducing the null values in tuples, and last one is disallowing the possibility of generating spurious tuples. So getting, guys? So these are the 4 guidelines. Next I am going to explain in detail semantics of the attributes. So semantics, what is going to tell, right? So it is going to tell that how to interpret the attribute value stored in a tuple of the relation. In simple words, how the attribute value in a tuple relate to one another. Don't get confused here. So in simple words, I can tell that while choosing the name of the attributes, you should choose the name of the attribute in such a way that, right, so it should be simple, it should be understandable. For example, if you want to give a name of the name attribute, if you want to use a name attribute of an employee, you can include an attribute as last name and first name. You can see by seeing that you can easily understand that the name contains 2 attributes, first name and last name. That means it should be simple. If when you see the attribute, you can be in a position, you should be in a position to understand the meaning of the attribute properly, right? So you can see here. So here employee table is there, department table is there, department location is there, project is there. So you can see there. So in employee table, if you see that, you can see each attribute have different names. For example, employee table contains employee name attribute, SSN attribute, birth date. Likewise, department contains department name, department number, like that. So you can easily understand what are the different attributes that a table contains. That's why semantics is going to tell that your attribute should be simple and understandable. Attribute name, right? So what is a guideline 1? It is going to tell about the attribute names. How attribute name should be. See, so according to the guideline 1, design a relation schema so that it is easy to explain its meaning. So when you see the table, you can easily understand that what are the attributes that a table contains. You can see there. Here, if you see this, you can easily understand that a employee table contains employee name, SSN, birth date, address, and department number as the attributes. Getting, guys? Next, see, do not combine attributes from multiple entity types and relations types into a single relation. That means you can't use same attributes in two or more tables. Right? Same name you can't use. Getting, guys? So if you are using a employee name as E name, you can't use department name as E name, because E name is for employee, D name is for department. Different attributes have different names. So do not combine attributes from multiple entity types and relationship types into a single relation. That is the first guideline. And also along with that, first guideline tells about reducing the redundant values in tuples. That means according to the guideline 1, no redundant value should be there. So because if redundant values are not there, it will save the storage and avoid anomalies. Yes, redundant values are not there, you can easily understand that it will definitely save the storage space. But what is this anomalies? Right? For example, if I say an update anomaly, there are three types: insertion anomaly, deletion anomaly, and modification anomaly. Along with the redundant values, your database should not contain these anomalies, that is insertion anomaly and deletion anomaly and modification anomaly. So I will discuss these three anomalies in detail now, so definitely you will understand that. So to explain this, I am considering two tables, that is employee department table and employee project table. Both tables I will consider to explain this. So first I will explain insertion anomaly. For example, if you want to insert a new employee tuple into employee department, for example, suppose if you want to include employee tuple, if you want to insert a record in this table, which table? Employee department table. What happens? We will see that definitely it will suffer from insertion anomaly. See, to insert a new employee tuple in an employee department, we must include either the attribute values for the department that the employee works for or nulls. That is, it's difficult to insert a new department that has no employee as yet in the employee department relation. So don't get confused, guys. It is very simple. So for example, you can see here, for example, if I want to insert a value to this employee department table, you can see here I have to insert ename, I have to insert SSN, I have to insert birth date, I have to insert address, and also I have to insert a department number, department name, and department manager SSN. Suppose assume that this employee doesn't have any department still, because no department is assigned for this employee. It is a new employee of a company, so no department is assigned yet. Now we have to insert that employee information without a department. So you can't insert the values for department number, department name, and department manager SSN. These three attributes will be empty. So this is called as insertion anomaly. Right? So these three attributes will be empty because that employee doesn't have a department details, because he is a new employee. Still the department is not assigned to him. So that's why while inserting, you can insert ename, SSN, birth date, address, every information, but you can't insert department number, department name, and department manager SSN. So this is nothing but a insertion anomaly. You can see here, right? Definitely it is difficult to insert a new department that has no employee as it in the employee department relation. For example, if in the same way, if you want to insert a new department, it doesn't contain any it doesn't contain employees, definitely again it is also difficult. See, I have to insert a department details here, but the department doesn't contain any employee. So obviously department number, department name, department manager SSN values can be filled, but employee name, SSN, birthday, address values will be empty because department is there but no employees are hired. Getting, guys? So that's why department details I can fill, but department doesn't contain the any employees still because it's a new department. Again, employee name, birth date, address will be empty. So this is called as insertion anomaly. So what to do when this type of insertion anomaly occurs? The only way to do is to place null values in the attributes for the employee, right? But the problem is, right, employee SSN here, see, SSN is the primary key here. Getting, guys, what is the problem actually? So assume that I have a department, new department with no employees. So I can easily insert the department details, but employee details I can't insert because it's a new department with no employees. So, but here in this table, SSN is a primary key. As per the rule, you know that primary key can't be empty. SSN can't be empty. So definitely, it is impossible, right? That's why this is nothing but it suffers from insertion anomaly. Getting, guys? So you can put null, but the problem is you can't put null for the SSN because SSN is a primary key. Right? So that's why this is a insertion anomaly. You can't, right, put an empty null value to SSN of a employee because it's a new department with no employees. That's why this is nothing but an insertion anomaly. So I don't want to drag this. Suppose if you have any doubts, please post your doubts in the comment section. Next, deletion anomaly. So for example, see, if you delete from employee department an employee tuple that happens to represent the last employee, for example, working for a particular department, the information concerning the department is lost from the database. Don't worry, guys, it's very simple. See, for example, you want to delete all the details of the employees from this employee department table, right? The problem is if you delete all the employee details, obviously along with the employee details, the department details will also get lost, right? Department details will also, you will lose the department details also because you can see here along with the employee information you are storing the department information also. When you delete the last employee of this table, along with that employee data, all the department data will also get lost. Getting, guys? It's very simple. That is deletion anomaly. Along with employee details, department details also will be deleted. It is not right, right? It is not right actually. It's very simple. Hope you are getting, right? So when you delete all the employee details, along with employee details, department details like department number, department name, department manager, SSN, all the other details also gets deleted. So what is the remedy for this? The remedy is you have to separate employee table and you have to separate employee and department table. Employee table should be different table. Department table should be different table. In that case, definitely deletion anomaly can be avoided because when you delete the employee details, only the employee table, right? Only the employee table details will be updated. The department table details won't be updated because it is a separate table. So To avoid the deletion anomaly, you can create separate for a table for employee and department. So, but here you can see here employee department both are combined here. When you delete the employee details, along with the employee details, department details will also get lost. That's why this is a deletion anomaly. Hope you're understanding, guys. Suppose if you have any doubts, please post your doubts in the comment section, right? And the last one is modification anomaly, right? So in employee department, suppose if you change the value of one of the attributes of particular department, for example, say the manager of department 5, we must update the tuples of all the employees who work in that department. Very simple, guys. See here, suppose if you update the manager SSN like 5, for example, employee that is simple. So manager SSN should be updated in all the places where it is used. Actually, it's very simple. Update anomaly, right? For example, here you have name, employee name, your manager SSN. You have updated the manager SSN for this particular employee name. For assume your employee name is Vishesh. I am updating the manager SSN of Vishesh, but the problem is you have to update the manager SSN for the Vishesh. Wherever the name Vishesh appears in the entire database, you have to update the manager SSN for the name Vishesh. Suppose name Vishesh appears 1000 times, you need to update the manager SSN 1000 times. Getting? It's very simple. When you update the manager SSN, you have to update the employee name also for that employee. For example, I told you, right? Vishesh employee name Vishesh, right? Manager SSN of that employee Vishesh, if it's updated, right? And that employee name appears 1000 times in a database, in each and every place that manager SSN should be updated. 1000 times you have to update the manager SSN for the employee Vishesh, because it is there 1000 times. This is nothing but update anomaly. You have to update that information in all the places where the name Vishesh exists. So this is updation anomaly. It is not right actually. 1000 times you can't do that. It's a tedious job. That's why. So you have to avoid this type of anomalies. So insertion anomaly should not be there, right? And deletion anomaly and modification anomaly or update anomaly should not be there if you are trying to design a database. Next is guideline 2. So what it tells? Design the base relation schemas so that no insertion, deletion or modification anomalies occur. It's very simple. If I already discussed these 3 anomalies, like according to that guideline 2, these 3 anomalies should be avoided. And also, along with that along with that anomalies, guideline 2 tells that reducing the null values in the tuples. Null values should be avoided. If you want to, if your database needs to be designed properly, you have to reduce the null values. For example, see here, if 10% of employees have offices, it is better to have separate relation employee office rather than attribute office number in a employee. Now we can ask a question, what is the problem here? How it is a problem? Because only 10% employees have offices. Other employees don't have offices, right? You have to insert only 10. If you consider 100 employees, only 10 employees have office values, office number value. Remaining 90 employees don't have any value. You have to insert null in that place. This is not a good idea. You know that, right? Because only 10 employees have the office. Remaining 90 employees don't have any office number. So that's why you have to insert null in that place. Instead of that, what you can do, if only 10% employees have office, you can create a separate table, employee office. Definitely, In that employee office table you can insert the details of the office. Instead of that, if you create a office number in employee table, definitely it is going to it's going to waste space, wastage of space, because office number will be only for 10 employees, not for the remaining 90 employees. Obviously, this office number attributes contains 90% null values. You should not design in such a way that it contains null values. Guideline 2 tells that you should avoid the null values. Null value should be as much, it should be less. It should be very less. You should avoid the null values. That is the second guideline. Along with that, no insertion, deletion and updation anomalies should be there. Getting? Next, guideline 3. What it tells? Avoid placing attributes in base relation whose values are mostly null. Right? I already told you, right? So you have to design a table in such a way that the attributes doesn't generate null values. Here I told you office number is generating the null values, more null values. You should avoid that. Also, along with that, disallowing spurious tuples. What is spurious tuples? Tuples that are not in the original relation but generated by natural join of decomposed subrelation. Right? Very simple. That means actually these tuples are not in the original relation. When you join two tables, these extra tuples will be generated. That extra tuples are nothing but spurious tuples. I will take the example. Definitely you can easily understand this. So for example, here I am decomposing. Decomposing means I have a table employee project. I am dividing that employee project table into two different tables like employee location and employee project 1. So when you do this, obviously it will generate spurious tuples. See, I will show with the example. Very easy. So you can see here, guys. So employee location table will have attribute employee name and project location. So here primary key is a combination of project location and employee name. That is a composite primary key. And the second table is employee project 1, right? Employee project 1, that is SSN, project number, hours, project name, P location. But the primary key again here, it's a composite primary key because it's a combination of SSN and P number, right? It is a combination of SSN and P number. So you can see here I am decomposing employee project. I am decomposing employee project into employee location and employee project 1. You can see I am performing a join here. So you can see Smith John B. So here you can see here Smith John B location is Bulgaria also, Sugarland also. This is a spurious tuple. It should not be like that, right? See again English, Bulgaria also, Sugarland also. Again Wang Franklin, Sugarland, Austin, Stafford. This is nothing but spurious tuple. When you join employee name and project location, so you joined a employee name from employee location table and project location from a employee project 1 table, you decomposed it. You decomposed these two tables into by selecting these two attributes. So this table is employee location. You can see employee name and project location, right? You are taking project location and employee name both, right? But the problem here is it is generating spurious tuples. That means same name Smith John B is having a project location in two different places. It can't be there. It is not possible actually. Suppose Bulgaria is the initial value here, but when you perform the join, Sugarland is included, inserted extra, because join, you are performing join for same tuple, two different values. So this is nothing but a spurious tuple getting. So what is the spurious tuple? Tuples that are not in the original relation but generated by natural join of decomposed subrelation. That is, employee project is decomposed into employee location and employee project 1. Getting, guys? Right? So here I decomposed. What I did, I took project location from employee location, and I took also ename from the employee project. Sorry, don't get confused here. So I decomposed it. Decomposed means I divided this table by ename and p location. So when I did that, when I did the join, so extra tuples are generated. That is spurious tuple. Suppose if you have any doubts, you can post your doubts in the comment section. Okay. Next is guideline 4. So what it tells, design a relation schema so that they can be naturally joined on primary keys or foreign keys in a way that guarantees no spurious tuples are generated. Guidelines 4 tells that spurious tuples should not be there, because definitely for a same value, two different project locations are there, right? This is not right actually. So you should avoid that spurious tuples. Guideline 4 tells that no spurious tuple should be there. And along with that, guideline 4 also tells about functional dependency. It's very simple. Functional dependency means it's a constraint between two sets of attributes from the database. I will explain with example, don't worry. But so far you should understand that it is denoted by x tends to y. Here x is one attribute, y is another attribute, right? We say that y is functionally dependent on x. We say that y is functionally dependent on x. Also, x is called the left hand side of the functional dependency, y is called the right hand side of the functional dependency. See, functional dependency is denoted by arrow x tends to y. X is on the left hand side, y is on the right hand side. You can tell that y is functionally dependent on x. Y is functionally dependent on x. I will take the example, don't worry. And also, a functional dependency is a property of the semantics of the meaning of the attributes. Right? That means if there is a functional dependency between the attributes, it will hold for all the records. All the records in the table should hold the functional dependency. Don't worry, I will take the example. But a functional dependency is a full functional dependency. When we have to call a functional dependency as a full functional dependency means if removal of any attributes from x means that the dependency does not hold anymore. I will explain, no worries. So a functional dependency is a full functional dependency if removal of any attribute from x. If you remove any attribute from x, dependency definitely doesn't hold. At that time, I can call that dependency as partial functional dependency. No worries. Now I will explain with example, right? See here. Examples of, see here, SSN is a x, ename is a y, x tends to y. Here y is functionally dependent on x. So according to the definition, y is full functionally dependent on x, right? Here ename is functionally dependent on SSN. Ename is functionally dependent on SSN. What is the meaning that if you remove SSN, if you remove ename or if you remove SSN, definitely if SSN is removed, you can't identify the name because SSN is the primary key. Getting, guys? if you remove the SSN, you can't identify the E name. That is, if you remove X, Y can't be identified. That is functional dependency. E name is functionally dependent on SSN. It is fully functional dependency. Fully functional dependency means you can't remove any of the attribute either in X or in Y. You can't remove SSN also, you can't remove E name also. If you remove E name, you can't identify SSN. Again, in second example, you can see here, P number is X, P name and project location is Y. Here P name and P location is functionally dependent on project number, right? For example, you can see here, that is P name and P location are functionally dependent on project number, right? Getting, guys? So what happens here? So if I remove P name, what happens? If I remove P name, I can't identify the project number only. If a P name is there, I can identify the project number easily. When I remove P name, I can't identify the project number. That's why it is functional dependency. Project name and project location are dependent on project number. When I remove project name here, I can't identify the number, because if a name is there, I can easily tell what is the project number. That is functional dependency, fully functional dependency. I can't remove any of these attributes. Here E name I can't remove. Here project name I can't remove. If it's possible to remove any of the attributes, then it is also called as what? Partial functional dependency. If you can't remove any of the attributes, it is what? It's fully functional dependency. These are the examples of fully functional dependency. Here in the first example also, I can't remove E name. In the second example, I can't remove P name, project name. In the third example, you can see SSN and P number. If hours can be determined by SSN and P number. If I remove P number, if I remove SSN, how you can find out the hours of that particular project number? If you have SSN, definitely you can find out the number of hours for that particular project. If I remove SSN, you can't find out the number of hours for that particular project. That's why this is fully functional dependency. So one attribute is dependent on another attribute. To know the hours, I need SSN attribute. To know the project number, I need project name. To know the SSN, I need employee name. So one attribute is dependent on another attribute. That is right. X is functionally dependent on Y. SSN is functionally dependent on employee name. So where you can't remove any of the attribute. That is nothing but fully functional dependency. I showed you, right? I showed you with the example. You can't remove any attribute here. If it's possible to remove any of the attributes, then it is called as partial functional dependency. So you can see here, FD is a property of the relation schema, not a particular relation state. That means functional dependency holds for all the values that is present in the table. If you have 5 SSN here, all 5 SSN definitely will be functionally dependent. If you have 5 E names, all the values, all the records will be having the functional dependency. Functional dependency is with respect to attributes, not with respect to records. Getting, guys? So, right? You can see here. So I don't want to confuse you guys, right? So that's it. So these examples, it is actually not necessary for guidelines. This much is more than enough. So in this video, I have discussed 4 important guidelines. That means while designing the database, you need to follow these guidelines. right? So hope you understood the concepts. Suppose if you have any doubts, you can post your doubts in the comment section. Thank you for watching the video.